as an IoT engineer. So IoT is a rapidly growing field, and to excel in it, you need a strong foundation in electronics, programming, networking, and cloud technologies. So start by mastering basic programming languages like Python and C, understanding microcontrollers and sensors, and gaining hands-on experience with IoT platforms and cloud integration. As you progress, work on real-world projects, and staying updated with industry trends will set you apart. We hope this session provides you with valuable insights and a deeper appreciation of the subject. With that, let's begin. We will start with PPT presentation led by Ms. Shweta and Ms. Indumadi, followed by a hands-on demonstration of the home automation system by Mr. Ramana Shankar. Thank you and stay tuned with us. It's over. Yes. Okay, good afternoon guys, I'm Shweta from Velgrow Academy. So we'll just start with a very light session on IoT and we'll move on with what we're going to do in the whole session. So first of all, you guys have heard what IoT was. So let's begin. So why IoT? So IoT is all about making everyday objects smart by connecting them to internet. So they collect data, communicate with each other and automate tasks without human intervention. So for example, your smart wearable watches, your smartphones, smart lights, and in a larger scale, smart agriculture where they have irrigation system, like automatic irrigation system, without farmers, have to do it manually. So that way, IoT has seamless connectivity for a smarter world. It optimizes the time through automation so that we don't have to always intervene and do things manually, and it saves us so much time, energy, and resources. And it also enables smarter living, working, and it is also has become an indispensable tool for modern life. So when there's a system, there are few components that build this system. So this is IoT. It refers to a system of interconnected devices, sensors, and software capable of communicating with each other and processing data. So this is like the cake on the handle. It cake on the mic and the handle. The mic. Check. Sorry guys. So this is the Google definition or the proper definition for what an IoT is. So we'll move on to, this is the basic IoT. So let's move on to the components of IoT. So the first component is sensors, actuators, connectivity, edge devices, cloud, and user interface. All these five consist of IoT. IoT is based on these four. So sensors and actuators are basically, a sensor is something that senses the movement or an environment and it collects data. That's what a sensor does. And an actuator, sorry guys again. So a sensor, an example is a temperature sensor, moisture sensor, or anything. I'm really sorry. So we'll move on. So the second one is connectivity. So anything which or connection between two devices is connected. Your Bluetooth, Wi-Fi, they collect the data. The data which is collected in the sensor is sent to the device communication protocol or a connectivity, that is your Wi-Fi and Bluetooth. Your third thing is edge devices. So where are the collected data going? So the collected data goes to the device there. And then next comes the cloud. So cloud basically comes between connectivity and edge devices. You can store the data locally inside that device, or if you want a wider range of analysis and filtering process, it is sent to the cloud. So for example, let's take a smart AC system. So, or I mean an air conditioner system. A locally stored data will have just on off according to whatever you want. You can set the timing, and then according to that it will on or off. That is one way. The next way is, if you want your temperature to be controlled via the weather forecast according to your temperature outside or humidity outside, you connect it to the cloud. So cloud over there, it will have a wider set of data which will help you to analyze and filter and process the data, and it will tell what next step to do automatically. It's like
another variant or wide range of analysis. And the last one is user interface. So everything that is processed, even though it is a machine, we need some human intervention in that. That's where user interface comes. So anywhere we can control and monitor that IoT system, it's via the user interface. Your mobile, your apps in your mobile, like I said, smart AC, they will have an app, right? That is your user interface. So these five are the components of IoT. Next, any system will have a set of architecture. Right. So IoT has 3-layer architecture. IoT has 3-layer, 4-layer, 5-layer, and various layer of architecture. But the 4-layer architecture is what we are going to see today, because 4-layer architecture is the most commonly and widely used architecture because of its flexibility, and it's also easy to use. Like you can modify it according to your needs. And it's very simple, and because of the flexibility, the 4-layer architecture is used widely. So the first architecture, so the data goes from down to up. From sensing layer to application layer, it's a down to bottom up, down to top approach here. So first we look at sensing layer. So what is the sensing layer? Sensing layer is nothing but, again, as I told you before, the components of IoT are also interlinked with this layers here. So in the sensing layer, the sensors, it collects data. That's all it does. It collects data from the environment. And we can also have something called an actuator. So what is an actuator? So whatever comments we give, the action is done by the actuator. So like for example, the robot arm here in the industrial automation sector is an actuator. Whereas in the car you have infrared sensor, pressure sensor, radar sensor. So all these, they just sense whatever is happening in the road, and the data is collected. So that is what the sensing layer does here. And another simple example is smart home. So in the smart home automation, the sensors with the light there, the sensors just detect the moment that someone is there, and then the lights switch on or switches off. So there it's collecting the data, and it just collects the data. It senses the moment, it detects the moment, and it collects the data. So next layer is the data processing layer. So this layer is the brain of the IoT system, or any IoT system. The data processing layer is the brain. So as I told, the data is collected from the sensing layer, and it's sent to the data processing layer in a raw format. So whatever data is collected here, it's in a very raw format without no separation or analysis or anything, because we won't need all the data all the time for certain devices or certain actions. So that way, it's given from the sensing layer to the data processing layer in a raw format. So in this layer, it analyzes, processes, and then filters the raw data which is sent from the sensing layer to the data processing layer. This is where the decision is taken on what is the next step for the particular system to do. So that is where data processing layer comes. I guess I have told you the cloud computing. Cloud computing is basically when it's sent to Google Cloud. So in our phone we have Google, all of you have a Google account, right? So in that we have a storage there. It's a cloud storage. So we have more data stored there. So when the the weather forecast I told, now you can relate actually. So the weather forecast is from the cloud. The processing and everything is done there. If you compare whatever is done locally here and in the cloud, it's a wide range of analysis and filtering and processing happening there. So this is data processing layer, and it deploys AI, machine learning, big data analysis. Because of every programming, machine learning, your programs which are you got to give it to the microcontroller or anything is in this layer. So next one is the network layer. So this acts as a messenger. So how is the data from sensing layer sent to the data processing layer? Via the network layer. So this comes in middle of sensing and data processing layer. So this helps. It acts as a messenger that helps data travel between devices or wherever the data wants to go. The network layer takes care of it. So Wi-Fi, Bluetooth, things like that are the network layer. And again, we come up to smart watches. So here we have, if you want the data just to be sent to your phone, your blood pressure, how many steps you are taking, your heart rate, everything is sent to the phone via your Bluetooth. All your smart watches are connected to the Bluetooth. But if you want that to be stored in a database or in a server for more analysis, for you to tell, these many steps you have to walk today, this much water you have to drink today, all that is via cloud. So that's a wider range of those data are sent to the cloud via the internet, 4G, 5G or Wi-Fi. That's where your network layer plays a role. Next is the last layer of the architecture, which is the application layer. So it's where the users interact with the IoT devices. So it provides a user interface for accessing IoT devices, and it contains some mobile apps, or dashboards, or web portals, and everything you want to see, like how much ever you have, this 1 month, how much water you have drank, or how many steps you have taken. Everything is shown in a data, like in a pie chart way or a bar graph, like however you want it. So that is your user interface. So this is where your application layer comes in play, and the smart app watch, again, that is your user interface. For the user interface application layers, example is one is smart watch app. So next, so now that we have seen all the 4 layers, how is the data collected and how is the transmission happening here? So it's very simple. If you understand, it's very simple. So again, if you look at just to go through how it's happening. So first, your sensors and actuators, they collect data. They just collect data, and then it is sent to the data processing layer for analysis, and then the decision is taken based on the analysis done by the data processing layer. So in the middle, your network comes in. The data is processed. Your network, Wi-Fi, cellular, or whatever data is there, it is sent to your devices, edge devices. That is where the data processing happens, and the decision is taken next to what step it is. So your that processed data is sent to the actuator. That is the device that does the action, whichever command you are telling. Again, we go back to the AC temperature example, so that you guys will have the flow of what we are doing. So AC, let's say this set according to your weather forecast, and you are telling your AC needs to be on. You send a command to the app or the phone, and that you just press a single button there, and then it is sent to the AC and it automatically on. So sensor, your action in the user interface, you are doing an action, and that action is sent to AC. So that is the actuator. The one which is executing the action is the actuator. So sensor collects the data, it is sent to the data processing layer, it processes the data, analyzes it, and it sees what is the next step for it to do. If it's too hot, your temperature will be low. If it's too cold, then your temperature will be like around 26 degrees. Everything, the decision is taken in the data processing layer, it is sent to the AC, and it will execute the action. So this is how the data is collected and the transmission process happens. Am I going too fast? can go deeper into it, but as simple as that, it's a very straightforward topic to be honest. So these are the few applications. So here if you see IoT is used in vehicle travel. So a sensor, it takes the movement of the tires, it is sent to a Raspberry Pi. This is the data processing layer. So the data is sent to the internet and to the cloud server it is stored there. It's analysis the data there and the action is showing back the vehicle tracking. If you take an IoT in vehicle surveillance, your cameras are the sensors that's detecting the image and that image is sent to the computer. There you have all the algorithms that will take care of identifying the car, and in your laptop in the same interface it will show what car it is or what detail you need. And now if you take, this is the home automation system which we'll be doing later in some time. So same, your phone will be your interface, these are the sensors, data is sent here, the actuator is done. And this is the industrial automation. Video is not playing. So in industrial automation, the robotic arms that assemble these, so the robotic arms that assemble the whatever we need to assemble, that are the actuators here, and the program will be sensors. So anything at all you take and it's not automated manually by human will be an IoT system. So this is for till now it's just an introduction to IoT and how the data and everything works. I'll pass on the mic to Indumati ma'am. She will explain the rest. Thank you.
Hello guys, I am Indumati from Velgrow Academy. Today we see about the IoT light automation light project demonstrations. It is a IoT based light automation demonstration using ESP8266 Wi-Fi module. Next. The project overview is about we developed the project using IoT based light automations. It is controlled like blinker using the switch on and off. When the switch is on, the bulb will glow. When the switch is off, the bulb will off. Next, what is using the project advantages is reduces the energy wastage, consumes the convenience to use. Next, what are the components are used in this project? We need Wi-Fi module, that is ESP8266, no MCU, not Wi-Fi. Next, LED bulb and relay module, and blinker for app control, smartphone or AC to access the blinker. Next, power supply, that we want 9-volt battery only. Next, jumper wire and breadboard for connection. Now we see the architecture of the project. First, we need sensor and actuators are connected to ESP8266. ESP8266 are connected to Wi-Fi module. When the user command to the button, it will on and off. Next, I hand over to Mr. Ramana Srinivas.
Hi, good evening. I am Ramana from Velgrow Academy. Okay. Today we are going to do the hands-on training. So this is the ESP8266 Wi-Fi model MCU. Okay. So this will generate automatically a Wi-Fi signal. Okay. Can you see here? This is the normal supply for the Wi-Fi module. Even though this is a Wi-Fi model, we have to supply, power supply. So we have 9-volt battery, and by using the C-type cable, USB cable, we can give the supply. Okay. And this is the normal filter input port. After giving the power supply here, automatically we have D0 to D8. This will act as an output. Okay. In this port, when you put the power supply, from this D0 to D7, we will get 3.3 volt output. Okay. So that output is given to the relay. So this is the relay model. So how they have seen this relay? Anyone in real time have you seen this component? Can you guess me anyone where this relay is available? Even in this room, the relay is available. Can you guess? Here, this relay where will be in this room, in this hall, where will be? Any guesses? Who is electronics component? You can guess where it will be. No idea. So it will be in the stabilizer, the AC stabilizer. To act as a switches, even for our IoT Wi-Fi module, it will act as a switch because we are going to on the AC bulb. Okay, that we need a switch. As a switch, it will act. Okay. So this here relay we have on VCC and ground. That VCC ground is connected to the battery connection. And that for non-labelable common contact, non-labelable, this is connected to the AC supply. Your bulb will be connected. Okay. So this is the circuit. Okay. Anyhow, we will guide you. Okay. Now we are going to one set of demo board. So we will guide you how to connect the component. Okay. And this is the normal circuit. From the relay Wi-Fi module, the output is given to the relay. Between them, we have a transistor. Okay. Why the transistor? Because our MCU load will give only 3.3 volt, but the relay will activate to 5 volt. Okay. To boost the voltage, we are using this transistor. So this is the so we are going to do the hardware parts. So Sweta will explain how to connect and deposition. Okay.
Can we start the demonstration? No?
I think only one bit is available, right? Huh? So we'll start the demonstration. We can pull the table. Can anybody can help to pull the table over here so that we can do the demonstration?
You guys have a breadboard with you, or only one breadboard is there? Only one breadboard. Anyone else has a breadboard here? No, okay. Are you guys aware how a breadboard works? The connection, everything is made. You guys are aware how the breadboard works? So, you guys are aware how breadboard works, right? Can you go on to the next step? Sir?
I need a group of people over here to be present. You are not going to the demonstration. You people are going to work out on this. Come on, no one is to do the demo. This is a workshop. Okay, this is not a seminar. So your ma'am told me this is a workshop, so there will be a 5 group of people will be having the POM so that you can able to do on your own. But to my surprise, workshop has become seminar. Yes, please come. Whoever is interested, you can come. 10 people also you can come. If you want to learn, you can come. Please. It's very easy and damn sure we are not going to ask any questions. Just whatever the instruction has been given, you are going to perform. That's all. Yeah.
I'll just quickly go through the connections for the breadboard. here. From here only we will be giving. So the above is a positive supply. The below, the minus, is a negative supply, or you can also tell it's a ground, or 0 volt supply is given in these two in the bottommost line. And if you see here, it's switched. So up the one above is the positive supply and the one below is the negative supply. Now, what is there in the middle? So in the middle here, the current flows parallelly. So all these 5 holes are one connection. From there you can give connection to one device or anything. And here is where we give positive supply. Now, here this part is divided into two. So here the current is flowing in the series. This is in series. So these like 5 holes are there, right? So these 5 holes have one connection. So when you are doing it there, you will understand it much more easily. So if you want to, these two are separate. But if you want to connect these two, you need to give a connection from the E row to the F row here. Okay. Now we'll move on. So next, we will be using jumper wires to have. So these wires, they are for temporary connections only. This won't be the permanent supplies for demonstration. For how you for temporarily, if you want to just test out a circuit, you can use jumper wires. So this wire, this is called a male-to-male wire, where you will have a male pin in there. Yeah. So I'll just set this out. So they both have a pin here. Are you able to see? These two, this is called a male-to-male pin, where it is used to connect two circuits on the board. So that is male-to-male. Now female to female. So if you take the board here, you can't do it with the male-to-male pin I showed you. So for that you need a socket kind of pin. So that is where female-to-female jumper wire comes in place. So from here to here, if you want to connect, you can use a jumper wire which has a female socket. So that is one type. And other type is male to female. One side will have a pin, and other side will have a socket. So see, this one has a female socket and other has a male socket. So if you want to connect the node MCU board and the breadboard, you use this jumper wire. So these are the 3 types of jumper wires we have. This is what is widely used. So now we'll start the demonstration. So first we have we have totally 3 components here. The relay board and the node MCU microprocessor board and the breadboard battery. We'll first look into the connection for the relay. So okay, so as seen before in relay there are 3 pins. Okay, in relay you have 3 pins. One is VCC. So I told you in the breadboard you have something called VCC. So VCC is given on the topmost connection of the breadboard. That is where we give power supply is taken from there. And there is something called a ground. Ground is nothing but zero supply. When a positive is there, you need to give a negative ground so that there is no short circuiting in the component. So there's a mistake here. This is a relay ground. So relay ground is given to negative supply. That is this line, and the VCC, that is the power supply, is given on the topmost part of the breadboard. So now this has a pin, right? So you take the female socket and you give this. So now and the next pin is given in.
Ask her to do it.
The next pin is given in ground. So all the pin VCC ground everything I'm telling is printed on the board of the device. Any microprocessor or anything you say the pin name and the pin number, everything is printed on the board. So you don't need to memorize which pin is what. There is the function of the pin you need to remember. Yes, VCC is to the positive supply and ground to the negative supply. So So once I finish it, we'll show you, I'll tell again where the connections are. Once they finish, I'll again explain to you guys how it is so that all of you have an idea how the connection is. Okay, so this is the first trick. Now, how will the signal go through the relay? What switch on or how it will go? For that only we have a pin called D in. That is the signal pin of the relay. So next we look into the connection of the signal pin relay. Now, there is one minor problem in this circuit. What does that mean? The node MCU, every board will be able to give only a certain amount of current from that board as an input. Okay, but the relay module which we are going to use needs a 5-volt supply, right? But the board we have can only give 3.3 volt supply. So there is a voltage difference between those two. So to connect that, we are using a transistor. What is a transistor? It's very simple. The transistor amplifies the current. So it will take a small current, whatever current you are giving, it will take a small current and it will give it to a larger current, to another device. For example, this mic. The mic I am using has a transistor inside. So if I'm talking like this, are you able to hear? Nothing. But when I talk here, the sound is coming. Inside this is an amplifier. A small signal is given in a larger scale. So for that only we are using a transistor here. So this transistor, there are 3 pins. Again, pins will play a large role in electronics. Everywhere you go, you have pins with different connections for various pins. So this is very easy. So you have something called a connector, a base, and a emitter. So now we'll be working with everything. Now the base is where you give the current, and that is where it will, pass on the current from this end to this end. The base does that work. So the whatever current we are giving in base, it will give it to the relay as the how much point it wants. For that, we are using a 9-volt battery. So now again, this 9-volt battery will give you 9 volts supply, right? But when it's freshly opened, yes it will. But after some time, the voltage goes to 5 or 7. But we need particularly 5 volt for the relay to work. So we are connecting this with the transistor, right? So now the signal pin is connected to the base. Here, the middle pin is connected to the base. Now, how do you work with the transistor? Very simple. There is the structure of the transistor is there is a curve here and there is a flat surface. If I show you so it's a very small component. If you see there is a curved surface and a flat surface here. So when you are connecting it, make sure it is facing the flat surface is facing your side. This is how small the transistor is. So this is how it looks. Right? So you make sure that the flat surface is looking your side. You see? So this is what a transistor does. So they are connecting that with the third pin of the relay transistor. Sorry, of the relay channel. And when you are connecting it, right? So now you have kept the base. How do you connect it with the base itself? It's already kept in the transistor is kept in a way that 1, 2, 3. 3 vertical lines you have to keep place the transistor like that. So now if you want a connection from any of this pin, you can either take the connection from the same line, whichever line you have kept the pin is. From the same line you have to take the connection. Because the same line they are connected. So from this you can give how many other connections you want. So make sure it's in the same line. Front or back, that doesn't matter. But it should be in the same line where the pin is placed.
Connected to negative. This is positive, this is negative.
So now we have done with this. Now relay connection is over. Now we need this. Now we are doing that. So the resistor will be like this. You just bend it like an arch so that it can be kept on the in the breadboard. So that is the next step. Now there is actually wait one minute. Okay, I'm extremely sorry. I did a mistake here. I'm really sorry. The first pin I said no, the relay pin, the signal pin is connected with the collector, and the first pin here is not the base. I'm extremely sorry. It is didn't see properly. So the first relay pin is connected with the base of the transistor. That was a mistake. Any confusion? I just said the pin wrong. Any confusion, guys? The relay, we'll show you again. Again, we'll show this and we'll explain this so that all of you can understand. This is giving you a insight on how it works. So the first relay is connected to the collector, and then we are giving one end of the resistor to the middle pin of the transistor. So yes. So now we have connected collector and base. Next is emitter. So that end is given to the ground or negative supply, because the positive supply one channel is given in the collector. Now a positive is given. We need to give a negative so that it's not short circuited. So one end, the other emitter is connected to the ground. Okay. Now are you able to see the picture, or is the picture clear there? Okay, we'll move on to next one. So now the board comes into play. We have finished the relay connection. Next is the board. So in the diagram you guys called something called a GPIO. You guys remember the pin diagram? You guys saw a pin called GPIO. Okay. So that only one pin we are going to use here. It's a digital output pin. So what is it, that GPIO pin that is there? It's a general purpose input output pin. So, for example, it has two functions. You can use that pin as an input and an output. Take your mobile phones. In your charger point is there, no? In the charger point, you can charge your phone and also send data from your laptop to your phone. That is called a general purpose input output pin. So, input is your charger. But you take files also outside, right? So, that is the purpose of that pin. Like that, there are many pins in that one board. You have one of the pin we will be using is a GPIO pin. The pin number is DO. It's a digital output pin. Okay. So that pin is connected to the resistor. Other end of the resistor. One end will be connected to the base pin to the transistor. Oh my bad. Here we connected with one end of the resistor. Now the other end of the resistor is connected to the DO pin of the node MCU board. That is a microprocessor. That processor only one pin, GPIO pin, which is like a 4A, so it has a multiple function. Two functions you can have. It's a general purpose pin. That's why it's known as a general purpose pin. So this is So the one end of the resistor is connected to the digital output pin. Now next, again we give a positive, right? The digital output pin is given to the resistor. Now we need to ground this. Give a negative supply to the board also. Every circuit, every device, remove to ground or give negative supply or 0 voltage so that it doesn't short or it won't burn, because if you use this for a very long time without a ground, the board will start to heat up. So sometimes it might burst, or maybe I have seen both burst. So be careful with that. So always remember to ground your devices. So now we are taking again in the same the DO pin that you can find is when you face the board like this. On your left hand or the right hand side, topmost pin is your DO pin. On the same side, if you come slightly down, you will see a ground pin. It will be spelled like GND. GND, that is your ground pin. That is where you give your negative supply in the board. That is basically 0. So that it's stabilized. When you give a power, positive power, you need to give a negative power, right? So we are grounding the board also. We grounded the resistor also, the transistor also. Remember, the emitter was connected to the ground. When you give a positive supply, you need to give a negative supply. So make sure you do that whenever you handle electronic devices. Next is, as I told you, are named in the board. So we have V, ground and VCC. So the VCC is your positive supply. Your ground is your negative supply. So the VCC is given as the yeah, here using the set of holes here. So the VCC, okay, this is the purple here is yeah, it's here. So the purple one is your VCC given in the positive supply. Your ground is your ground number one, is a negative supply. So from these wires are made to females because this is a pin wire. So it's a socket shape and it could have been very easy only made components with you and breadboard. We have the signal pin. Signal pin. This is yeah, this is the connection pin. Okay, now we need from here. Now see, all these three nodes, it is connected in one hole of the breadboard. So now, if you we need to give it the same connection, so you give it in the same line. This is V in. Okay, now this is over. This only this comes here. Now this is over. Now we need to connect our board. See, so board is there. Now here you have everything in named. All this has their name. Okay, so if you want to, this is like an example. If you want to know what it does what, go to Google, type this. We can ask for a data. Get your data. Okay, now this is the view of an activity. This is a general purpose bit. Your phone, like a phone. Now we are doing this as an input. So we are charging the phone like that. Okay, so here, this one is one end of the receiver. The receiver is connected like this. Have you installed it already on your phones? Keep it in the same. Now, one is overlap that we are giving it to the you already signed up on that road. Okay. Have you signed up on the base? The middle. I think you are signed not regulated by burst or unnecessary current to go. Already signed up and all. You know your board will also get affected. So for that we are regulating. One end to the sink, the middle base of the battery. So understand. So again, we need connection for this. So we will next one is in the same way. Okay? Because we tend to not see it properly connected like this. Okay? Now, these two pins are done. Now what is that? Emitter. Emitter is there. What connection will we get? Negative connection. Because the positive is given here. So now we are grounding. So grounding is basically nothing. And this is connecting here together. So same like. Okay? Here is there. So this is the same line. This is what the connection is, and you have to ground. Again, this is the away. The same like you have ground. So that is grounded here. Negative. And now this is the back. Now we are given positive supply here. This is negative. Okay, the transistor because it's a 9-volt battery. After signing here, because what next coming from here is only 3.8 volt. This 9-volt battery is not freshly opened to work just like that. But it has to go, like it has to start using it, the current will drop to 7. 9 volt fully won't come. So for that to regulate that, we are giving the transistor so that 5 volt exactly goes to the thing. So when you name your textbook, which one name you want to have, just pay your pen, everything. It's very simple. I mean, you would have seen elaborated and I was explaining, but when you see it, this few components, the breadboard connection might alone might confuse you. So this is there. Yeah. So this relay is there. So this relay is there. No. V is connected to the one end of the mobile collector. collector is where it is going. Here. This is the pin, no? The collector is here. It's going in the same range of it. So that's how the signal is going. All these lines have the same point. Like in that socket, if you want to get current from the main, we are giving lines throughout our home. So like that only. So from one point, you can give many connections. From our main, we have any number of devices are connected in our home, right? So when you give that, from one point only we are taking all that. So like that when you want a red code, because it's a very miniature of that. So when you want that, you keep one component here, and the same connection is only here throughout this line. So that is how you connect. Make sure you connect to the same line. Here, anywhere you can take and give power supply, that's all fine. But when you are giving here, make sure it's all in the same line. Okay? Any doubts? Any other questions? This is what we'll software and see more. Please, next set of
Hi guys. You guys know what? Come this side. Come here. It's fine. Come here. You can come and stand here. Come here. Yeah. Okay. You guys are aware of the components, right? This is the relay. This is your node MCU. So node Wi-Fi module node MCU. That is the full name of the board. Okay. So this is the board. We have a 9-volt battery. We have a relay. So and we have a transistor and we have a transistor and a resistor and a transistor. My bad. Okay. Now we will see the connection of the relay. So in relay you have all, as I told you, all the pin names will be printed on the board. So you don't have to memorize it. Just remember what the pin does. So here you have in pin, okay, and you have a ground and you have a VCC pin. So now VCC is your positive supply, ground is your negative supply. So now see. Now, okay, I'll take this out. So now see, VCC, this is your VCC pin. Okay, now this is a male to female connector. This is your female side, this is your male side. Now, this is connected to the negative side of your breadboard. You see a line, right? The negative side. The below one is your negative side because like A, B, C, D I told you, you have to hold it in this way. So here in this side, it is negative, positive and negative. Here it is positive and negative. So we use this side. This is mostly used so that you won't confuse. So just remember the upside alone. Above it's positive, below it's negative. So here we have connected the VCC in the positive board, and now the ground you have. Ground is connected in the negative supply. This is a positive supply, negative supply. Now we need signal from that. We need somewhere to use the signal. So now what do we do with the transistor here? Now this transistor, do you guys remember the pin how we showed you there? They are not sure. Okay. So you have 3 pins, collector, base and emitter. Now this VIN is given to the collector. Here, I will show you guys. Wait. Here, this is the VIN. See, the transistor is very small. So I'll take this out. See, this is your transistor. You make sure you give it in 3 separate ways. 1, 2, 3. Okay. When you give connection, I'll take this also. See, this here. You give it like this. Just be gentle because the pin might break. Now this is given to the collector here. So when you keep the transistor like this, the flat side facing you, it will be like this: collector, base, emitter, C, D, E. Remember Coimbatore, C, D, E. So collector, base, emitter. So the VN is given here. This is done. The relay connection is done. Now we need a transistor. Why do we need a transistor? So as I told you, this transistor will, why do we need a resistor? This transistor will, what does that means? But it will give you a very little current, but it will give you much bigger current. Like the mic example. I'm not talking very loudly regularly, but with the mic, my voice is heard to a very long distance. So for that, same concept. Small current which is given to larger. This only can give 3.3 volt. but we need 5 volts for the relay to run. Through this only we are giving commands to this, and this is running now. So in that way we have to, this has to be given 5 volt current, but this gives only 3.3 volt current. So to regulate that, to act as a switch, we are using the transistor. Now the base, the middle pin of the transistor is what makes the current flow from here to here. Within the transistor, that is what helps it. So we need to regulate that also. If you give more current there, the transistor might burst, overheat, whatever might happen. So for that we are using a very small current, that is the resistor. This is just a 1 ohm resistor, very small current. So that is connected to the one end of the transistor, sorry, of the resistor. One end of the resistor is connected to the base. Now be careful with this. We are taking the connection from the same line. Okay, this is where this line is only, the middle part is there. So this resistor you have to keep it in the same line as wherever it is. Okay, now we are given this is in the same line as the center base. So now I'll tell you how this is basically work. So we have our mains at our house, right? So from that main only we are taking current for our refrigerator, TV. If any connection is taken from the main, one point with different lines like that. If you one point different lines, so all these have the same connection. So from one point you can take various. So you connect your main here, you take refrigerator from here, or your TV from here, your socket from here, your microwave from here, all in the same. As long as you give it in the same point, it will work. Okay, so we are giving 1 point. Now this is done. We have connected the base and the collector of the transistor is done. Now we have our board. This board is your node MCU ESP8266. Okay, now this is your, if you look again, I told you, right, all the components, the pin, the names will be on the board. So now we are using this pin called DO. Okay, do you guys remember a GPO, something written on the pin diagram? Okay, I guess you won't. Okay, fine. So there are some pins where you can use which has more than one purpose. Now take your phone. In your phone you have charging point. No, you can charge your phone as well as use it to transfer data from your laptop to your phone to laptop. So you giving charge to this is, we can say it's an input. From your phone you are taking the files, that's an output. So it's a general purpose input output pin. Now here we are making this an input pin. So now this is now these two are there. Okay, now this is an input, this is the ground. Now we have to, whenever you give a positive supply, you need to give a negative supply to the device also for it to stabilize the circuit. Now this is given to the other end of the resistor. One end to the base, other end to the resistor, because that is what is sending current. The base is only sending that small amount of current to here, and the other end of it is sending it to the relay. We have given two connections now on the base. So one base, the current will go to the base from the board. It is sent to the collector. So that collector will give 5 volt to this. That is how the connection works. Now you have to ground this. The other same side, if you see, you will see something written as GND. There is GND in this side also. Any one GND you can use. There will be more than one ground in one board. Okay. So this one we are going to, oh my god, we are going to ground this. Anywhere, give it in the negative side. Okay. Now we need to ground our transistor also. So the one, whatever is left, emitter is left, we are grounding that too using a male to male pin. Again, make sure you give it in the same line as your emitter pin. Okay. Now 9 volt battery. This is the battery I was telling. This is what will give you the current which needs to go to the 5 volt. This will go here and then here. So now we are going to the negative to the negative, positive to the positive. Any doubt with pins or any connection doubts? This is simple. Like when I was explaining, it would have been very elaborate, but when you see it, it's very simple, I guess. Any doubts you have? No? And we will move to the software part once everyone finishes seeing it. Okay? Thank you. Guys, next set of people. Guys, anyone else wants to see the connections? Anyone else who wants to see the connection? Anyone else, guys? So we'll move on to software. Okay, then we'll move on to the next part of the demonstration. So hardware is done. This is your hardware component. Have you guys installed your no, not yet. App வச்சிருப்பாங்க. Have you guys installed Blink IoT app with you? Is it there? They have. Okay. Don't. Wait. Hello guys.
Have you guys logged in? Signed up or logged in? That's done.
Miss, you have to select the order ESP8266.
And connection type it may be Wi-Fi. Next, the description is optional. Give description or not.
If you found the template, did you find create new template? Over. Next screen. What is the next screen you are seeing on your phone? Are you guys seeing a create new template? Yes or no? Yes or no? If you answer only, we'll be able to help you guys out. It is new template, huh? You have given the name of the template, no? Yes, what is that? Is are able to find where this? You will see a spanner on the top of your app. Right hand side top. You see a spanner. There is no spanner button there. A green color button there, right?
Create a new template.
After creating the
Okay. Done. After creating a new template,
Next, on your phone, see on your right hand side, there is a green color button. Spanner button. You can see it.
Just go there and just follow the instructions.
okay.
Any name, once you convert, you just name the content. Any name, George, so you name it on.
Next one.
நிறைய பேர் இன்னும் இதுல வேற மாதிரி இருக்குங்க.
ஆமா.
இல்ல அவரோட
கரெக்டாக இருக்கு. அப்படியே போயிடலாம். Next.
அப்படியே உட்காந்து பாருங்க. Oh, you open it in your desktop or website.
Already template is created.
அவங்க ஆப்ல ஓபன் பண்ணுங்க.
அது வேற மாதிரி இருக்கு. சரி. டோட்டலா.
Desktop appear Chrome la panna
Chrome okay. Okay, guys, we'll do one thing. Have you guys signed up? Okay, now this will be much easier for you to navigate. Go to your Chrome. Type Blink IoT website. That's more easier than your Chrome. Go to your Chrome. Open your Blink IoT website. Just type Blink IoT website. You open it and log into whatever you signed up. That's much more easier to see. And change your desktop to your Chrome. See, when you open it, you can see the screen like this. Go to the website. Okay, type Blink IoT website in Google. The first thing that pops up is
If I give login and explain.
Now, you see something called hardware. You see something called a hardware. Press it down, you will see ESP 8266. That, please. Through Wi-Fi we cannot communicate, right? The module and the board with the app. So click that. Now, give done. Give done. Okay. Okay. What do they see on the screen? Did they see this one, which is data stream or web dashboard? Do you see that? Go to data streams. Click data streams. So this is where the very connection. You're going to operate through data streams. Okay. When you open data streams, you will have a site like this. New data stream. You see that? Click that, and you will have a number of options. Go to virtual pin. Okay. Click new data stream and press virtual pin there. Give option as virtual pin because you're going to connect it virtually, right? We're going to operate it virtually. So you give virtual pin. You have digital pin, analog pin, but give virtual pin. That is how we are going to communicate virtually through Wi-Fi. Got it, guys? Done? We move on. Now go to web dashboard. Below data streams, do you see a web dashboard there? Do you see web dashboard? Below data stream, do you see web dashboard? Now, when you see web dashboard, a screen like this pops up. Is it popping up? Do you see the screen? When you read web dashboard, you see the screen? Here, girls, are you able to see web dashboard? When you click that, are you getting that? Everyone, you need help, let us know, okay? Are you able to see that? Done, we'll move on. Sure, we'll go. Now, see, you have something called the widget box there. The first one is a switch. Click that switch and keep it in the dashboard next to it. Okay, this is the web dashboard. This part is called the web dashboard. The name of that part is web dashboard. Okay, click. You either double tap this switch, it will appear there, or drag it and keep it in the web dashboard. Are you able to do it? Either drag the switch and keep it on the web dashboard, or double tap the switch. It might appear on the web dashboard. Are you able to do it? It's drag it. Done? Everything is done? We'll move on to the next one.